Hi friends, welcome to the last problem of the Stat 111 final live solve. Charlie says hi, and he'll soon get really mad at me for picking him up. But this is problem 6. It's a tank problem. Okay, I'm putting Charlie down. Here you go, baby. It's a tank problem, adapted. And yeah, let's get right into it. I'm gonna make my face a little smaller. Boop. There we go. Okay, so you're given limited edition collector's item book, of which only N copies exist. You have little information about how large N is. To assess how rare the book is, you wish to estimate N. The Jth book printed was inscribed with the number J. Your book turns out to be number 111. Assume that your copy is equally likely to be any of the N copies of the book. Okay, so the first question asks, find the maximum likelihood estimate for N. So the only information you have is your book, which is like, I guess, Y equals 111. So the likelihood is going to be Ln, and this is going to be the probability that you observe your data. So like it's going to be some sort of P of Y given N. And note that there's just like N books, like 1 through ... N. So we could have selected any of these at random. So it is going to actually just be 1 over big N. And the support here is going to be N has to be less than our data. Or sorry, N has to be greater than or equal to our data, 111. So this is our likelihood. And if you were to graph this, you would get something that looks like this, but discrete, which is continuously decreasing. So our MLE, and oh wait, also it's going to look more like from here to 111, it's going to be 0. And then here downward, it's going to decrease. So we're going to select our MLE right here to maximize the likelihood. So our MLE N hat is going to equal 111. There's a cat crying next to me. So here's our MLE. And next for the method of moments. So the method of moments says that the theoretical mean is equal to the observed mean. So our observed mean is just 111 because that's the only thing we saw. And the theoretical mean is going to be the, it's going to be what is the average number that you observe from here. So that's going to be the sum from some of I from 1 to N divided by big N. And that's going to end up being the median number. So that's going to be N plus 1 over 2. So this is N plus 1 over 2. And solving this will give us our method of moments, so our mom estimator. And this is going to equal 222 minus 1 equals 221. So this is going to be our method of moments estimator. And then finally, using the prior proportional to 1 over n squared, find the posterior mean of n in terms of one or more of the constants defined like this. So we have posterior n given the data is proportional to the likelihood times the prior. So the likelihood we have up here, it's 1 over n. 1 over n, and I guess like also the indicator that n is greater than or equal to 111. The prior is going to be 1 over n squared. So this is going to end up being, it's going to be proportional to 1 over n cubed, and n has to be greater than or equal to 111. Okay, and we have to make sure we have like, so this is going to be the just what the posterior PDF is proportional to. So we have to normalize it. So let's say we will need c over n cubed from n. I guess I'll call this like c, yeah, c n cubed, just to match this, from n equals 111 to infinity. I need this to sum up to 1. So solving this, we get c equals n equals 111, infinity 1 over n cubed, which is going to just be this, this is equal to c sub 3. So now we want to find the expectation, or I guess what we have now is that this posterior is equal to c3 over n cubed. So now what we're looking for is this expectation, the posterior expectation, and we just put this into the definition of expectation. So from n equals 111 to infinity, we have, we're looking for n times this PMF. And this is going to equal n equals 111 infinity, and then c sub 3 over n squared, because one of the n's will cancel out from this n. And this is equal to c3 times the sum n equals 111 to infinity of 1 over n squared. And then this stuff here is going to be, oh wait, I think I solved this wrong. Let's see. Oops. 1 over c is this, which is equal to c3. So actually c is equal to 1 over c3. Just a reciprocal mistake there. So we have 1 over c3 here, and this guy up here is actually 1 over c3. Okay, so here we have 1 over c3 times this, and then this is c2. So in all, we have c2 over c3 is our posterior mean. Yeah, so I think that's it for, so that's it for this final live solve. Hope you guys enjoyed as usual. I guess this is technically like my last live solve ever, so sentimental. And yeah, I hope you guys, wish you guys luck on studying for the final. Whether you're watching this year or in future years, or whenever you're watching this, maybe you missed 111 in the summer and you're gonna watch this for nostalgia. Who knows? But yeah, had a great year teaching for you guys, and good luck on the final.